Hello. All right. Hello. As he noted, I'm Dan Goodfriend, CTO over at MediaSpa. I won't tell you the other parts of this, but I will tell you that my primary roles at MediaSpa include defining application architecture, structuring integrations, overall solution architecture, and the occasional firefighting. A little bit about MediaSpa. We are a Magento SI with boutique agility, enterprise experience, and I'd invite you to talk to some of our team members who are here today, Gary Beneroff, Andrew Pokowitz, Allison Williams, and Deb Poppleton. So, I am here to talk to you about microservices with Magento architecture. The purpose of this discussion is to cover a specific implementation of microservices that we did for one of our clients, KidCo. I'll delve into some specifics about that, but I will focus on what prompted us to go down this path. So a couple of questions. Why do we have microservices? When do we use microservices? And why did we use it on this particular project? So, quick note. Here's why we love microservices. Okay, they're highly maintainable and testable, loosely coupled, not necessarily tied to each other, independently deployable. We'll talk about that in a second. Organized around specific business needs and capabilities, and owned by a small team. So, I'm sure some of you are familiar with monolithic architecture. That's me right there. In the beginning, there was the monolith. Monolith means single giant stone. And unless we're that guy, we don't want to be doing that. So monolithic thinking results in spaghetti code. Spaghetti code has an absence of unified objectives, right? You have documentation that has not been maintained. An evolution, maybe your code base is 5 or 6 years old. Dev team members have left, and the client has changed their original objective. Monolithic thinking results in code deployment nightmares. So imagine that you need to launch a small subsystem of your application. Well, when you launch that, you have to test the entire application to see if there have been any impacts on it throughout the site. You have to do regression testing. Potentially, that will result in some downtime. And it involves greater resource requirements. You have to get front-end, back-end developers, multiple people looking at something when all you launched was a very small subsystem. And overburdened infrastructure. So this is your standard stack for Magento, Nginx, PHP, Redis, Memcache, Varnish, and MySQL. Hopefully you're not using that on a single server, but this overburdened infrastructure can result in cron overlaps. So let's say you have a product import, and that product import runs every 15 minutes. And then one day, without any notification, the client introduces 5,000 more SKUs. Your cycle is now completely changed, and you encounter cron overlaps. Oops. Within Magento, you're going to get some error reporting, but it's not great. So then you're going to have to diagnose, is this a server issue? Is this an application layer issue? And auto-scaling the whole application. Again, if you have a single feature that you want to release as a microservice, and that feature is getting overburdened, you have to scale up the entire application, and that can be expensive. Again, draining shared resources. So when do we use microservices? For us, it's about moving data. And we think of integrations in 3 forms. One of those forms is going to be a direct integration. You're APIing directly into Magento. Another would be middleware. Middleware, some piece of software that handles information on one side and pushes it into Magento. And then microservices. Microservices is a lot like middleware, but it's broken out into individual, highly specific components. So, direct integrations. That's when you want data to move one way. Inventory levels, price. It's difficult to do chained events, right? If your cron has gone long, there's no way to tell the next event not to run. And no data transformation. We talk a lot about ETL, extract, transform, and load. Direct integration doesn't give you the opportunity to modify the data as it moves from one side to the other. And again, you're going to get very basic logging. Middleware, that's when we start to see the introduction of ETL scripts. And you can use one of these vendors or build it yourself, but this is the start of bidirectional communication. And it's usually with a single source. So Boomi, eBridge, Celigo, they're usually going to be tied into a single piece of software, your CRM, your ERP. And you'll be able to get some more detailed logging in there. It's also the first introduction of a file server. You're not going to use that in a direct integration. If that service is dropping XML files, a piece of middleware will allow you to use SFTP. And it's also the first time you can introduce the business logic, the T in the ETL. And then we get to microservices. So microservices focus on very specific, discrete functions. And we'll talk about one of those in a second. This is also for high-speed transactions. All right? If you need to manipulate data very quickly, a microservice is an ideal solution. This is also where you can introduce some very complex business logic. And by isolating it into a single application, you're able to maintain your business logic layer separated out from your presentation layer, and you're not going to get this kind of overlap of spaghetti code. Tighter security, that's another thing that a lot of people don't take into account with an application like Boomi or eBridge, and that's doing a number of different things. Moving orders, moving shipments, moving inventory, pricing. Who has access into that? And how do you separate out permissions? It also produces the greatest amount of flexibility. So, here's the meat of it. Why did we use microservices on our project? You able to see that? It's a little fuzzy. So, our client is KidCo. KidCo is a Canadian company, and they buy and sell precious metals. And they have variable pricing. Very, very variable. So we created the pricing microservice. So this snapshot actually is this section of this page for purchasing a 1-ounce silver kangaroo coin. And what you'll see is that we actually have a pricing matrix. And the pricing matrix is driven by multiple factors. The first one is volume. So based upon the number of those 1-ounce coins, you can get a reduction in the per unit price. Payment method, right? MasterCard, Visa, PayPal, they're going to take their 2% or 3%. Our client doesn't want to have to pay for that. So if this is your payment method, they're going to upcharge you. They're going to try and recover that fee. Same thing with Bitcoin. The one thing that you actually won't see here is the customer group, but that's another variable. So now for a single product, we have 11 prices. And why is this so critical? Well, they sell expensive products, right? You can buy 400 ounces of gold. So fluctuation in that pricing can be astronomical. Is gold volatile? Hint, yes, okay? This is a snapshot of 1 day, actually it's about 8 hours, and you can see the price of gold has changed from around $1,400 an ounce to about $1,540 an ounce. Do currency exchange rates fluctuate? Sure. This is from a couple of days ago. This is the Canadian dollar to the US dollar. This is 1 day. Change isn't as great as it is with gold, but it's still material. So we've got these multiple independent factors that drive the pricing of that product, that silver kangaroo. One of them is the customer group. So they've got a variety of different customer types. They've got your regular collector, they've got investors, they've got regular retail customers. And what they want to do is incentivize each of those individuals by giving them price breaks. So the customer group drives price. Payment method. We saw up here, based upon your payment method, you're going to have a different price. And volume discount. An interesting thing about this is that this volume discount is not across the board. For each individual product, they can set the tier levels and then the discount. So it's a lot of information, again, for this single product. And then there's the metal price. So that product has a cost that is driven by metal price as a major factor, and that's coming in and modifying every second. Next item is promotion. How do they charge for their product? Well, they aggregate all of these pieces of information, the variable metal price, they put their overhead in, and then they draw that back by using a promotion. And then you have exchange rate, another method of modifying these values. And finally, volatility. And this is where the meat of our microservice came in. The pricing microservice allows for the price of every product to change every second. Imagine having to deal with indexing and caching in a situation like that. It'd be a nightmare. How do we do that? Well, first thing we do is we pull in the metal price, and we do that every second. And then we take in the currency exchange rates every second. The user can go into an administration system and modify certain fixed variables, such as what the upcharge is for a payment method or for tiered pricing, and they can install promotions. But the key here is how we manipulate the price on the front end. If we were to do this every second, it would be a nightmare for a user. Imagine looking at that matrix of 11 different prices and seeing each one of them change every second. It's untenable. So what we've done is we've put a minute stop on there. So every 60 seconds, we update the value that is used in our calculation. All right? So even though this is coming in every second, we cycle it to every 60 seconds. Same thing with the currency exchange rates. Now, in order to protect the client, we have to put in a tool to manage volatility. So gold can change quickly. Largest one-day change in spot gold, 8.9%. In 1 day, it changed that amount. So we have to implement safety mechanisms. And this is all within this microservice. So everything's normal. We run it every 60 seconds. We retrieve that data, and we send updates. Additionally, because the customer is adding items to their cart, the minute they add it to their cart, they have a 5-minute counter. And every time they modify that cart, 5-minute counter starts up again. And the price is fixed at that moment. But if you've got a lot of volatility, and that price drops dramatically, then the client, our client, can take a massive loss. So what we do is we build this volatility index. And that is looking at these calculations every second and determining, is the price of gold or rhodium or palladium changing at such a frequency that we need to make modifications. And if it does, it triggers a refresh rate that's a little bit faster. So now, instead of displaying this every minute, it's every 30 seconds. And we shorten the time that they can be in the cart without the price refreshing. So we're down to 2 minutes. DEFCON 2, the next level, and these are all arbitrary levels. These are things that they would set within the microservice to determine what these levels are, but when it reaches that threshold, refresh rate increases, and the cart timer goes down to 1 minute. And finally, when we get to DEFCON 1, we have our kill switch. So what this does is it will automatically identify a volatility level that is too much for the client, for our client, KidCo, to handle. And what it will do is it will immediately suspend sales. They also have a mechanism for doing this manually, but we're talking about massive amounts of money. We're talking about transactions in the hundreds of thousands of dollars, and a few seconds isn't enough time. So the kill switch. A couple of things about some issues with microservices. Multiple infrastructure elements. What does that mean? Well, with monolithic development and architecture, you always know where to go. Your Magento application, your MySQL database, right? Maybe you go and look in caching. But by introducing microservices, you now have a number of different places to look. And then a lack of cross-application knowledge. Maybe somebody who was working on the account microservice isn't familiar with the pricing microservice and has no idea how to make a fix there. Lack of consistency. So you can create your microservice in any number of different languages. You can use Node.js, you can use C#, you can use Laravel, or you can go serverless. So your developers now need to know all of these different languages. Potentially, it's a drawback. And finally, unique data spaces. So imagine in these various microservices that we're using with our client, the data for date is not consistent, right? A lot of people store dates in different formats. So now, you have to make sure that you're translating that information in between these various systems. And that can be a headache. But I'm up here because I love doing microservices. And the benefits are the 2-pizza team rule. That's a rule that Jeff Bezos implemented. And the idea is that your development team cannot be larger than the number of people it takes to eat 2 pizzas. So keeping your team small, hyper-focused. Independent scaling abilities. I can't stress the importance of this enough. So in our pricing microservice, if we're in DEFCON 2 and we've got to process this extraordinarily fast, maybe the server that this resides on isn't powerful enough. But we can scale it up. Or we can implement auto-scaling. And that has no impact on the application, the authentication microservice, the account microservice. And independent deployment cycles. If we want to make a modification to any one of those microservices, we can do so without having a deployment for any other parts of the application. One of the other advantages is multi-system accessibility. So this microservice is sitting there processing pricing information, and we're doing it for a Magento website. But they have different channels. They've got an app, and they've got a call center. And both of those systems need to get the exact pricing information that our pricing microservice has created. So it's not just for your Magento application. And you most certainly wouldn't want third-party systems trying to retrieve data out of Magento. And then the last advantage is serverless technologies. We're really just starting to get into that, but there's some really exciting things that we can do with Amazon Lambda. So that is my presentation.
All right. Thank you very much. Who has questions for Dan? There are microphones right in the middle of the room if you'd like to come and ask your question.
Thank you very much for that really great example of usage of the microservice. So the question that I actually have a few. So in your experience, what's the max number of microservices that were used in one project?
I don't think there is. There was a conversation with Bezos about what his system looks like, what his entire infrastructure and architecture looked like. And he has all of these different microservices with different teams. Somebody asked him how many he has. He says, I have no idea. So there's no practical limit to it. If you have a need and you can extract that need and focus it within a microservice, then do it.
Nice. And then having multiple microservices within one project, how do you share the common components? So for example, some abstractions which interacts with
how do you share common components?
Common components like abstractions, like for example, abstractions for models, for controllers.
Sure. So one of the other elements that we've done, and I hope this answers your question, is we've created a brain microservice. And the brain microservice contains all of the business logic. And so they're all going to feed off of this center center microservice to retrieve their data. Does that make sense?
Thank you. It's a little bit different question. So it's not about the data. It's more about the code itself.
In this scenario, it doesn't matter, right? It doesn't matter because the code may be entirely different. It may have a completely different function. Maybe you can do it in serverless in one technique and not in another. So there's really, these are discrete features, discrete functions. So there's really no need to share.
Okay. All right, thank you.
So if I have a traditional brand.com website and an e-commerce sites that are separate today, right? And you could skin that cat if you wanted to combine those a million different ways, iframes, all kinds of other things you could do. What's the argument for leveraging microservices in that environment? So, you know, big high volume brand.com website, traditional e-commerce. What would be your recommendation on something like that?
Well, I think is the juice worth the squeeze scenario. What are you doing 2 times, right? What are you repeating? Where is there an opportunity for human error to enter in a promotion on one side and not on the other? And if that's great, then you start to think about implementing microservices. And you also think about what your plan is for 18 months down the road. Are you going to introduce an app? Are you going to introduce PWA? What else are you going to use that might leverage this microservice? And again, remember that the microservice really only needs to do one specific thing, and it should do one specific thing. It's okay to bundle them together into a single application, but the idea of this is to focus on that objective.
Anyone else have a question for Dan?
Hello. Thank you for a very interesting presentation. I would like to know how far did you go with serverless?
I'm sorry, how far did we go with?
Serverless. AWS Lambda, for instance. Have you ever used it?
So we're doing one of the microservices serverless right now. And it's a difficult question. The answer is usually based on manipulation and logging, right? If I couldn't do the pricing microservice serverless, and the reason why is because there needs to be human input. I need to be able to go into this system and update my promotion or change the tier pricing for a particular product. I need to have a GUI, right? So that application needs to be Laravel hosted on some EC2 somewhere. So serverless we use when it's very, very simple calculations, modifications, transformations of data.
All right. Thank you.
All right, any more questions? Wonderful.
Well, this isn't really tied to the microservice, but I was curious about how you guys handle the cart timeout, like when the person about that gold price, when you put it's because it's so variable, when you put it on a cart, and when by the time you check out, there will be a price difference.
Right.
So how you do it?
So we deal with that by knowing that, yes, that price is going to fluctuate. It's going to go up, it's going to go down. When I add that item to the cart, I've got 5 minutes to check out. If after those 5 minutes I have not checked out, it will refresh the price, right? So the idea here is 5 minutes is enough time for the price to go up or down, but not dramatically. But that's why the volatility index is so important, because if you're starting to see massive changes in price within 5-minute spans, shrink that time and force the price to reduce even, to change even quicker, right? And then you finally get to a point where you say, we don't want to sell, it's too dangerous. But they take a chance. Sometimes they're going to lose money, sometimes they're going to make money. Yeah, so within our cart, we've got a countdown timer identifying how much time they have. And it will refresh if I change the quantity or add another item to the cart. And it'll go out and retrieve the price.
All right, who wants the last question? Anyone? Bueller. All right. Let's give it up for Dan one more time. Great job.